What's up, everyone? This will be the second video of my high voltage testing. Kind of look like a mess right now. My dog just decided that it was time for me to get up, so I haven't really gotten myself together yet. Hey, say hi. So anyway, I realized something the other day, and that's that the quality of the videos that I've been posting decrease quite a bit when I upload them to YouTube. I was kind of disappointed that you couldn't see what was on the screen on the scope, or at least the values. So that kind of sucks. I'll think about using a real video camera. It's just so convenient to do it on my phone and just hit upload. So I have some interesting things to show you today. So yeah. Okay, so I'll try to hold the camera as still as possible. But what I have today are these two tubes hooked up. These two tubes. And this is going to be more of a, this is completely a qualitative test. I'm not taking any measurements. They're not hooked up to the same thing. This tube right here will be the high voltage, like the whole, Stanley Meyer, whatever, VIC, or it's more like the A times A in this situation, sort of similar. And then this tube here will just be average everyday electrolysis. So the idea is that electrolysis is all based about how many electrons you're not. It's all about redox reactions, and so how many electrons are actually moving through the circuit. And that's how much hydrogen and oxygen you're going to get out. So what I'm going to do is set both tubes so that they're at the same amperage. Obviously one will be at a very high voltage, and if one tube is producing more than the other one, or one with the high voltage, we should know that something special is actually happening, and that is not just ordinary electrolysis. There we go. You got to remember to focus. Okay, so let me turn this on. Okay, so it looks very similar to me, almost exactly the same. See a readout. Oh man, you're probably not going to be able to see that. It's, there we go. So 1.5 amps, and that is the high voltage. Which, if you remember, is this one. And then over here, we got 1.5 amps, and that's at 5 volts right now. There's no electrolyte in this, of course. But yeah, like I said, it looks like it's producing exactly the same, which is not very surprising. I should have picked two better tubes that didn't have wires in the way, but you can see that pretty well. Cool. Check the scope. Maybe I can focus on it. So this is the high voltage waveform. I could ground out the negative spike. I just don't really want to right now. So it looks like that, but I could ground out that negative spike. I just don't really see a reason to do that. Let's see if we can get an actual reading of this. 146 volts peak to peak. I've got it up to about 300, but I don't know. I can usually do somewhere between this and 300 volts. I don't know what's going on with the frequency right now. That shouldn't be like that, but who knows. Anyway, so it's kind of fogging up in there, but looks like the same production. So what I really want to do is get all the tubes hooked up. Hopefully this week I can do that. And then I need to go back to school for finals for about a week and a half, and I'll be home again. And I actually want to measure this, the difference in output. So I think that's it. Oh, the inductor that I'm using, I actually really like it. I made it out of 2 identical microwave oven transformers. I just cut them apart and put both primaries on the same core. It seems to work pretty well. I'm happy with it, and obviously it's great for 60 hertz, and that's all I'm really using here, even though that the scope said otherwise. But that's kind of a lie. I don't know what's going on there. Maybe it's picking up something. Maybe I don't know. I'll figure that out. Anyway, cool stuff. Maybe I'll make it an ending part of this video, explaining better what I'm actually talking about. Alright, I guess I should probably talk about the results of the experiment and why I did it in the first place. I kind of wanted to do this for a long time, and I don't know why I haven't up until now, and I plan to continue to do it when I have a better setup. It should be thousands of volts and not 150. But anyway, someone said something to me on the internet that really just bugged me a lot. I'm not going to tell you who it was, and there's a lot of people out there, so you'll never guess. Anyway, I suggested this experiment quite a while ago to some people that were further along than me. This was years ago. And then I had heard the same sort of something that bugged me maybe a few months ago. What I wanted to do was hook up, the high voltage circuit and measure its production, and then whatever amperage that was at, let's just say it was at 1 amp at the high voltage circuit, at 1 amp at 1,000 volts, that would be cool, 1,000 watts. And then, right next to it, you took another measurement of the same sort of cell design and everything, but normal electrolysis, no amp restriction, 1 amp at 2 volts or 5 volts, whatever it takes to push that much amperage through your cell, depending on what kind of water you got in there. So basically, you were looking at 1,000 watts compared to 5 watts. Now, if there is nothing here, if Stan's stuff doesn't work at all, or if my particular setup or whatever is going on, if nothing special is happening and it is just electrolysis, you should have the exact same amount of production. And I'm not sure if everyone understands that. I'm sure a lot of people that subscribe to my channel, because most of them are pretty good people, or at least really they know what's going on. They're doing their own experiments. But every once in a while I hear, like, obviously the one with 1,000 watts is going to produce more hydrogen and oxygen. Well, that's not necessarily true unless something is actually happening different than electrolysis, which would be really cool, and that's what we're all after. But it's because it's all based on the amount of electrons that are moving through the circuit. 1 amp is so many, like, trillion electrons or something ridiculous like that. I can't remember the exact number. But it's how many redox reactions, and if you're not familiar with chemistry, I would suggest you really get into that, because it's cool stuff and you should know if you're going to work on this stuff. But yeah, the watts don't matter in electrolysis for the most part. Obviously it does for energy consumption, but just speaking electrolysis wise, those 2 scenarios that I gave you, if there was nothing else happening, they should be producing the exact same amount of hydrogen and oxygen, because their amperage is the same, which means the amount of electrons going through the circuit is the same, which means The same number of redox reactions are occurring in the cell. The same number of ions are moving back and forth through the cell. But if there was something happening with Stan's technology, you would want to see an increase, obviously with the high voltage cell. And that's kind of been my theory for a long time, that it's hard for me to believe in any sort of over unity thing because I spent too much time in science class maybe. But what are you doing? Hey, go lay down. What was I even talking about? Oh, what I thought for a long time was maybe he invented an alternative to electrolysis, one where you didn't have to put chemicals in the water and you're still bound by thermodynamics, and that would be really cool. You know, it would solve some inherent problems that are going on. Man, I'm making this video really long. Should probably try to wrap it up. So main point, in electrolysis, same amount of amperage, no matter at what voltage, should be producing the same amount of hydrogen and oxygen. We saw in this experiment, qualitatively, it didn't look like anything extra was being produced, but then again, we're only at 150 volts. And this is sort of something I thought about a lot when looking at Stan's demo cells, that they were not the real deal, and they were more or less to show that you could restrict amp flow. And that is exactly what I've seen here, and obviously the voltage wasn't that high in those either. And I think if anything does happen, it's at quite a much higher potential, and in the other cells that we've seen. So that's why I did this experiment. I hope I explained myself clearly. I'm not always the best with that if people aren't here to ask me questions about it at the same time. So, did I miss anything? Oh, I did see, side note, Max Miller had one of his cells hooked up, kind of a tube cell like this one, obviously much constructed much better, but I guess it sort of does the same thing. It looks prettier, I guess I would say. His tubes aren't coated in anything, and he was getting an effect where with one tube was on, there was current leakage in, and other tubes were running just off of that, which is interesting. That doesn't really happen in my cell at all, and that's actually what I was trying to stop when I got these tubes powder coated like 5 years ago, or whenever it was, probably close to that, maybe 3.5, 4 years ago. So that was pretty cool that I realized that powder coating actually stopped the leakage current for the most part. Yeah, so if you have any questions about what's going on here, or maybe I didn't explain something, or maybe you want to argue, leave a comment or send me a message. Thanks for watching.